Hello, this is Miraj Patel, and today we're going to be talking about polyatomic ions and transition metals, the metals that we didn't cover in the last video. And so here we have the first PowerPoint about transition metals. And basically, we already talked about these normal ions in the A groups. And so pretty much the A groups, they lose or gain uh, 1, 2, or 3 electrons, and that pretty much just changes their charge, and pretty much they lose or gain enough electrons to have 8 valence electrons, or have a full valence shell. But then these transition metals here, they're weird, and they can have multiple electrons lost and gained at this, and actually they only lose electrons, so they can maybe lose 2 electrons once, and they can lose 3 electrons, and so it's weird how they can lose two numbers of electrons and still have an octet, but they're always positive, so just know that they're always positive because they're on the left side of the periodic table. And again, like I was saying, transition metals, they can lose 2 different numbers of electrons. So for example, Fe can lose 2 electrons or 3 electrons. And then nickel can lose 2 or 3, and then same thing with all of them. And there's only 2 transition metals, zinc and silver, that lose 1 number of electrons all the time, and it's 2 and 1. So just think zinc and silver, zinc and silver. And so here we're just going to do this exercise for these two transition metals and show you about, just tell you about how they lose electrons and stuff. But don't worry, you don't have to do this. It'll just, on the tests and worksheets, the valence electrons lost, and the charges will be given to you. So there's nothing to worry about the charges. You just want to show you that how the charges can change. And so here we have the electron configuration for iron. And so you know how we went through 1s2, 2s2, and so on, so on. And then here we have uh, the configuration, so we can figure out how many valence electrons there are by looking at the highest level, which is 4. And so there's 2 valence electrons. And what will the charge of the ion have? And so they can, it's weird because iron can either lose these 2 valence electrons like you expect, or it can lose 1 extra to get rid of this double pair, and it will have a charge of 3 plus. And so the weird thing about transition metals is they like to lose this valence electron, or they like to lose 1 electron, so they have all these singles. And so let's look at the next element, which is zinc. And so the configuration is 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, and 3d10. And then how many valence electrons does zinc have? It has 2 valence electrons, and you can see from the ring. And what will the charge of a zinc ion have if it lost a few? And so zinc, like expected, only loses 2. And I said that that transition metals like to lose either their valence electrons, or they like to lose it so that all of them are filled in, or all of them have 1 electron. And so because zinc, it has all these full, it only likes to lose 2 electrons, and only 2. And so moving on, so here we have a transition metal in a ionic bond. And so here we have tin fluoride, which is used in toothpaste. And first, like always, we write the atomic symbols, then we write their charges. And so fluorine, you can see from the periodic table, has 7 electrons, and so it only needs to gain 1 to make an octet, so it has a charge of -1. in SN, which is tin, it's given in this Roman numeral. So this Roman numeral tells you the charge, and it's always positive, so just remember that. And then we cross the charges like always, and that's how we get the formula unit. And so let's do one more example. We have tin sulfide, which is used for glazing for porcelain, for like your toilet and stuff. And so so first we write the symbols, and then we write the charges on top, and then we cross the charges like always. And just to remind you again, the Roman numeral tells you the charge, and sulfur is just an element, so you can look on the periodic table and figure it out. Sulfur has 6 electrons and needs 2, so that's how you get the 2 negative. And we just cross the charges, and because these both can be divided by 2, we simplify it, and so 2 divided by 2 is 1, so when 1 crosses over, that's how we get this. And then 4 divided by 2 is 2, so it crosses over. And so we have 2 sulfur and 1 SN, or tin. And so it's important, we just talked about transition metals use Roman numerals to show charges. And if it's non-transition metal, it has no parentheses. This is only for transition metals because there's 2 types, so we have to distinguish between which type we have. And so here's a quick quiz to see what you learned. So when metals are in from group 1, 2, and 3A to form cations, the charge on the ion is equal to A, 8 minus the group number, B, the group number minus 8, C, the periodic number, or D, the group number. So when you're doing when you're finding the charges of cations, which are positive, we just pretty much just look at the group number, or 1A, 2A, and 3A, and that is the charge. And so you can just know this from experience. And so the answer is D, the group number. And you can figure this out because in 1, 2, and 3A, they like to lose some electrons. And if we lose 1 electron, we'll be 1 plus. If we lose 2 electrons, we'll be 2 plus. If we lose 3, we'll be 3 plus. And so that is how, if you did not know that, but I'm sure most of you knew this just from looking at the periodic table multiple times, that you know that the charge for 1A, 2A, and 3A is the same as the number itself. And so what is the correct name for this ion? Cu2 plus. And so let's just go through how to name this. And so first of all, it's copper. So, and the answer has to have copper in it, and so all of them do. And the special thing about copper is it's a transition metal. So what do transition metals have that's special? Parentheses. So if you see a transition metal, it must have parentheses in its name. So there's only one answer with parentheses, C, and C, the parentheses answer, tells the charge, and the charge has to be in Roman numerals. So sorry about that. There are 2 answers with parentheses, but 1 answer has it in Roman numerals. So whatever's in the parentheses has to be in Roman numerals. So it can't be D. And the Roman numerals tell you the charge of the atom, which is always positive. I remind you that. Always positive. So the correct answer is C, because it's in parentheses and the charge is correct. And so what is the correct symbol for lead 4 ion? And so Pb5 minus, Pb4 minus, Pb5 plus, or Pb4 plus. So first of all transition metals have a positive charge. And so you can eliminate A and B because those are negative charges. And then also, this is the Roman numeral for 4. And so the correct answer has to have 4 and has to be positive. So the only answer that has that is answer D. So that is how I would get to the answer. And what is the formula for iron 2 iodide? And so we have first, what are the steps to write the formula? So first we write the symbols, so Fe and I. And then we find the charges, so iron, it has to tell us because it's a transition metal. so it has a charge of 2. And then iodine, or iodide in this case, has a charge of 1 minus, because it needs to gain 1 electron. And so we cross the charges. So iron has a charge of 2, so it gives it to iodine, which needs a 2 as a subscript. Subscript. So iodine has a charge of 1, so that will be given to the iron. And so iron will have 1 at the bottom, which is not seen. So the correct answer is B, because iron has 1 and iodine has 2, or iodide. And so the correct answer is B. And here's the last question for this round. And so the correct name for CrCl3 is blank. And so is it chromium chloride, B chromium 1 chloride, C chromium trichloride, or D chromium 3 chloride? And so first of all, chromium is a transition metal. So if it's a transition metal, it must have parentheses. So it must have parentheses. So the only two answers with parentheses are B and D. And this time both of them have it in Roman numerals, but we don't know the charge yet. And if you remember, to go to this before we did this step, like crossing over the exponents, we first wrote their charges. So we can just cross back the charges. So Cr will have a charge of 3 plus, and then chlorine will have a charge of 1 because there's an assumed 1. And so that is correct. So that is how you do it, because you can check, because chlorine has a charge of 1. And so the charge for chromium after crossing back this 3 is a 3. So the answer with the charge of 3, and this one says 1 and this one says 3. So the answer that says 3 is D, and so that is the correct answer. And so the next PowerPoint we'll be talking about polyatomic ions, which aren't much different. They're just ions that have multiple atoms. And so poly means many, and atomic is atoms. So polyatomic ions are ions that have multiple atoms in them. And so here's the correct definition. So polyatomic ions are tightly bound groups of atoms with an overall plus or minus charge. And so here are examples of polyatomic ions. So NH4, which is ammonium, and is a 1 plus charge. SO4, which is sulfate, and then nitrate, and then phosphate. And so here are some common polyatomic ions you'll be working with in this unit. And don't worry about remembering these. You will be given a reference sheet. So unless your teacher says otherwise, well, when I was learning this, we had a reference sheet, and so you don't have to remember this, so don't worry. And so all you have to do is pretty much know is the charges and how to make the formulas with these polyatomic ions. And so the main difference is polyatomic ions have multiple atoms, and monoatomic, or just normal ions, at least the anions end in IDE, but polyatomic typically end in ate, so like nitrate, chlorate, sulfate, phosphate, and then we have some weird ones that like hydroxide and ammonium that don't end. So that's typically end in ate, and most of them have oxygen in them. And then monoatomic, like normal, they're only one atom, and you can figure it out from the periodic table. But these, you'll be given a chart with all their charges. And so they have the same, pretty much same rules. So here we're going to go through them again. So first we write the two symbols. So calcium, we write the symbol, so Ca, and then nitrate on your polyatomic ion list. You can look. And nitrate is NO3. And then we write the charges like always as superscripts. So C has a charge of 2 plus because in column 2A. Then we have NO3, which is given to us. It's a charge of -1. Then we crisscross the superscripts and get it to the bottom, so we know the number of each element. And then we erase the charges. But the only difference is when you crisscross the charge to a polyatomic ion, and if you don't do anything, it'll look like 32. See how this 2 you just put it next to the 3, and so it'll look like the 32. So the only difference is you have to use parentheses for multiple polyatomic ions. So you must use parentheses, for example, around this NO3, because we want 2 of the whole thing, not just 32 oxygen. So 2 of the whole thing. So we have to just distinguish it with parentheses around the whole thing. So remember, the parentheses are pretty important. And so here's some more examples. So here's the first one, ammonium nitrate. And so first we look on our polyatomic ion list and find ammonium, which is NH4 plus, and then NO3 is nitrate, again from the polyatomic ion sheet. And the 2 charges, we write them, and then we cross the 2 charges. And because these 2 charges are just 1 and 1, we just leave the notation just like it is. So we just squish it all together in NH4NO3. And here we have the next problem. So we have calcium phosphate. So calcium is an element, so we can look on the periodic table. It's a 2+ charge because it's in 2A. Then phosphate is PO4 and has a -3 charge. So we cross the charges like always. So it's Ca3, and then because we need 2 of this ion, PO4, so we put PO4 in parentheses and put the 2 outside of it. And we have the last problem, iron carbonate. So iron is a transition metal. So this sort of combines what we've learned in the last PowerPoint with this polyatomic ions. And so iron, it gives us the charge, so it's 30+. Carbonate is on the polyatomic ion sheet, and carbonate has a charge of 2-. And this is how it looks. And then we cross the 2 charges, and so Fe will have a 2, and then because CO3 will have 3 of them, we have to put CO3 in parentheses and put the 3 outside, and so it's Fe2CO33. And so here's a quick quiz to see what you learned about polyatomic ions. And so which of the following are positively charged polyatomic ions? And so let's just go through these 3 ions. So ammonium ion. Ammonium is the first one on mine, so it's definitely a polyatomic, and it has a charge of 1+, so it is positive, so we have to have 1 in our answer. And then 2, nitrate. So the nitrate ion is NO3, and it's negative, so nitrate is definitely not it, so because it's asking for a positive ion. So nitrate is eliminated, and iron is not a polyatomic ion, so we can eliminate 2 and 3, and so the only answer that works is 1, so A. And so here are their charges and their chemical formulas again. And so what is the correct name for MgOH2? So is it A, magnesium oxide, B, magnesium hydroxide, C, magnesium 2 hydroxide, or D, magnesium 2 hydroxate? So first of all, you can look on our polyatomic ions, and you can tell this is a polyatomic ion because it's OH together in parentheses. So OH is hydroxide, so the answer has to have hydroxide. So it's not A or D. And so the charge for magnesium is 2 because you can get it by reversing this cross. because that was a step we did before. And then magnesium is not a transition metal, so we don't need parentheses because magnesium will always have a 2 plus charge. So we don't have these parentheses, and it's just B, magnesium hydroxide. And so here's question 3. What is the correct formula for copper sulfate? So copper 1 and sulfate. So let's just do the problem anyway, like we would do normally without these answers. So Cu is copper, and then sulfate is on the sheet, and it's SO4 2 negative, so it has a negative 2 charge. So we write Cu and then SO4 negative 2, and we cross the charges. So 2 goes to copper, and just by looking at that, you can eliminate down to C because that's the only one where there's 2 of coppers. All these have only 1 copper. And then the copper's charge, which is 1, goes to SO4, which doesn't change it at all because there's already 1 SO4. And so that is how you get C. And see how the charges are here, and then we crisscross them. And so here is the last question for today. So which one of the following formulas is named correctly? A, let's sodium bicarbonate. So let's just go through all of these. And so A, sodium bicarbonate. So sodium is Na, and it has a charge of 1 plus. And then bicarbonate is on the polyatomic ion sheet, and it's HCO. So this says CO3. This is just carbonate. So carbonate and bicarbonate are two different things. So this is incorrect because it's supposed to be HCO3, not CO. And so potassium nitrate. So potassium is K, and then nitrate is NO3. So this is NO2. NO2 is nitride. So this is nitride instead. So this is incorrectly named. Then let's look at sodium acetate. So sodium is Na. Acetate is C2H3O2, and they both have a charge of 1, but sodium is positive, acetate is negative. So C is the correctly named ion. So we can just check lithium sulfide. So Li is definitely lithium. SO4, let's just see if that's sulfide. It's sulfide. Well, sulfide, this is a trick question because sulfide is not polyatomic because this is just a normal ion. So sulfide is just S. So SO4 is definitely not sulfide. So that's how you get the answer. And so I hope this helped you learn about the two different chemicals in ionic bonding, transition metals and polyatomic ions. So pretty much for transition metals, the main important thing is to know that their charges change because they can have two versions of themselves. And it's important to know that they have Roman numerals and they're always positive. And then polyatomic ions are just pretty much ions with multiple atoms, but they overall have a charge. And so it's remember to put them in parentheses when you need multiple of one ion. Don't just put it to the side because that will just mess up the whole ion. And thank you for listening, and I hope you have a good day. And the next video will be wrapping up Unit 5, Ionic Bonding, and talking more about the bonding and formulas and stuff, and the properties of ions. And so, I'll see you later.